Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is to sum in Java. This is a problem and we are implementing this problem using two-pointer approach and also HashSet approach. So let's get started. Okay. So to sum using two-pointer approach. So first of all, let me explain what is the problem. So given an array and given a target, you have to find out the pairs which gives us the target. For example, 2 plus 4 gives us 6. Again, 2 plus 4 gives us 6. So why we got two pairs? Here we are having the 2 times 2 and 2 times 4. And again, if we take like 1, 3, 2, 2, 6 or 3, 1 as an input like 4. So our target is 4. This is the target and this is the array. So what will be our output? Like 1 and 3, 2 and 2 will be our output. 1 and 3 and 2 and 2. So this is the simple approach. So how can we find out the two sum? So we can use the brute force solution, but I think you all know how to do the brute force solution for this problem. Because if we have 2, 4, 2, 4, so first of all, the first for loop will be here. 1 minute. Okay, first for loop will be here and second for loop will traverse this whole array and we will check 2 plus 4 is equal to 6. Yes, 2 plus 4 will be printed. Okay, and again 2 plus 2 is equal to 6. No, 2 plus 2 is equal to 6. No, uh, the first for loop will come here and second for loop will traverse from here to here. 4 plus 2 is equal to 12. Sorry, is equal to 6. Okay, and 4 plus 2 is equal to 6. It is giving, see how many times it is giving. So this is the actual brute force solution for this problem. But here it actually takes O of n square solution. But the solution actually takes O of n log n. Is there any better solution? Yes, of course we have a better solution. We can discuss it later. But this solution takes O of n log n. So why it takes O of n log n? So let us discuss. So first of all, the first step in this like two pointer approach is, first of all we have to sort the array. Yes, we have to sort the array. So for only sorting only it takes n log n, because uh, actually quick sort or merge sort, they actually take the n log n time. So that's the reason the internal like we also have the predefined thing in the Java, like arrays.sort, it actually takes n log n because it is internally implemented using the merge sort. So this takes of n log n time. Okay, so that is the reason this method is like of n log n. Okay, the first step is sorting the array. No, so we want to sort the array like 2 to 4 4. When we sort this array, we are getting 2 to 4 4. And two pointer approach is something like, here there will be first pointer at first and last pointer at last. What we are doing? Okay, 2 plus 4 gives us 6. So if this first pointer and this last pointer adds and gives the 6, then we can print that pair and we can forward this last pointer and first pointer to this first pointer to plus 1 times, last pointer to last. And again we are doing like 2 plus 4 giving the 6. Yes, 2 plus 4 giving the 6. Now again this comes here and this comes here. But this is the first pointer, this is the last pointer. But we have the while condition that last pointer should not be less than the first pointer. So then the loop starts and this will be returned. Let me explain the same example with some other examples so that you will understand it. Okay. For example, take this. So this is the array. So what is the first step? We have to sort this array. Like 1, 2, 2, 3, 4, 6 and 7. Okay. We sorted the array and my first pointer is here and my last pointer is here. Now I want to check if 1 plus 7. Okay, sorry, I have not given the target. My target is like, let me take my target is 4. My target is 4. Is 1 plus 7 gives 4? No, 1 plus 7 will not give me 4. So what I want to do is, now I want to just change f to f plus 1, because if I change 7 less, so 7, this previous element should like 1 minute, I will explain it again. The process here is My first pointer is here, my last pointer is here. If I sum up these two, 8 is greater than my target. What is my target? 4. 8 is greater than target. So my target should be less. Sorry, my actual sum should be less to reach the target. Am I right? So my target is 4 and my actual sum is giving 8. So I want to reduce the sum. So to reduce the sum, I have to move this left pointer to one decrement, because like if we come from last to front, this is in the ascending order, we have sorted the array, so obviously this previous element will be less than the 7, so there is a chance of getting the less sum. So if we do 1 plus 6, 7, again the 7 is greater than target. Again I want to move this last pointer to here. This is my last pointer now. And again I want to check if my 1 plus 4 is giving, so 1 plus 4 is 5. Again my actual sum is greater than the target. Now what I want to do to lessen this, I want to decrement the L. That's fine. So now my 1 plus 3 is giving me 4, exactly 4. So now I can increment this first pointer to plus 1. Now I want to decrement this last pointer to minus 1. Now I can do 2 plus 2, again giving me 4. Now again I am making my first pointer here and my last pointer here. But at while loop, I am writing that my f should always be less than L. Means my first pointer should be always less than L. But here my first pointer is greater than L, so I will stop the loop. My answer will be 1 and 3 and 2 and 2. So this is the simple approach for two pointer approach. Okay, for finding the two sum. Now let's start implementing this. Okay, let us start. So I have created a new file that do some using two pointer approach. So what I'm doing now is I have taken the integer n and array input, now target input. Now what is the next step? So first of all, I want to initialize the last and first. So my int first will always point to the starting one and my int last will always point to the n minus 1. That's fine. And again, let me take sum, actual sum to store the sum. Sorry, actual sum is equal to 0. Now I want to run a while loop while my L is less than, while my uh, sorry, first, first is less than last. So what I want to do, first of all, I can store that actual sum is equal to array of first plus, array of first plus array of last. This is the first step I want to do. Then I want to check if my actual sum reached my target. Like if my actual sum is equal to target, then I just want to print that one. Like what can I do now? Okay. System.out.println. What I can do is my array of first, okay, plus and array of last is giving me for simply for beauty sake. Okay, so that's fine. That's totally fine. What happens if my actual sum is less than the target? What happens if my actual sum is less than target, or if my actual sum is greater than target? Then what I want to do, I just want to decrement this last to minus 1, because if I decrement this, then I can surely guarantee that okay, that element will be less, so I can reach the target. Okay, or else simply else condition is, or else simply do this plus 1. And I have forgotten one thing here. If it matches the target, then I want to do the both things, like last minus is equal to 1 and my first plus is equal to 1. That's also fine. Okay, let me save this. This is the very simple implementation of two pointer approach. Now let me run this. This no Java. do some using two pointer dot Java. Wow, there are many errors. Oh, sorry, I have not declared the data type. Let's save this. Okay, now no errors. Then just I want to run this. Using two. I want to give the input no. So let me give input as 5. Then 1, 2, 5, 3, and 2 again. My target is 4. See, it is giving 2 plus 2 is equal to 4. So why it is not giving me? Okay, I have forgotten the simple step to do. That one is sorting the array. That I have forgotten that. Okay. Arrays dot sort. Okay. Arrays dot sort of array. That's simple thing. Let me save this and let me. Okay, now let me give the input 5. 1, 2, 5, 3, 2. Then 4 is the target. Okay, 1 plus 3 is equal to 4. 2 plus 2 is equal to 4. This is a simple approach using the two pointer, but it is taking off and log in, but sorting the array. So how can we do? How can we do it using the hash set now? Okay, implementing this using hash set also, it's a very easy implementation. Okay, will not take much time. Okay, let me discuss about this hash set problem. This is also one of the collection in Java. This does not guarantee the order of the elements in it, and it also does not sorry, it also does not store the duplicate elements. Okay, now it does not guarantee the order. Order will not be maintained and no duplicates. And another important and wonderful thing for this is we can retrieve the data in O of one time. So that's really a great thing. So this can be done in O of n log time, sorry, O of n time, but there is only the additional space requirement. That's okay. So how can we implement that? For example, let me take the same example like 1, 2, 5, 3, 2, and there will be the hash set with me. First of all, this hash set will be like empty. Now what I'm doing is, this is the 1. So first of all, what I will do, my target will be 4 no here. I will check whether my target minus this array element, like array of I. Let me store this in like in remaining element. So if I do, for example, if 1 plus 3 is equal to 4, then 4 minus 1 will be obviously 3. Means this is the element 1, this is the element 2, and this is the target. So if I do target minus element 1, then I can find whether this E2 is present in hash set or not. Then that will be the pair which gives the sum as the target. Now what I'm doing, reminder is equal to this target minus array 2. Or I can also simply say that for your convenience, like element 1 is equal to target minus element 2. I will check whether this element is present in this hash set or not. No. Okay. If it does not contains, okay, but here see my element 1, sorry, element 2 is now 1. My target is 4. 4 minus 1 gives me simple 3. Is 3 present in this hash set? Now let me clear this also so that you will be better understand about this concept. Okay, let me take another color. Like my E2 is equal to target minus element 1. So first of all, my element 1 is 1. I am traversing from the start and my target is 4 now. Is my target means 4 minus 1, 3 is present in hash set? No, it is not present in hash set. So what I am doing is, okay, then I will add this 1 into this hash set. Then okay, now I will go into the 2. Is my 4 minus 2 is present in hash set? No. Then I will add this 2 into this hash set. Now again I will go here. Is my 5 minus 4, that is 1. Sorry. Target 4 minus 5. 4 minus 5 is minus 1. Is minus 1 in the target? Sorry. Is in the hash set? No, it is not in the hash set. Now I can ignore this. Okay. I want to add this. Now again, is my 4 minus 3, that is 1. Is 1 is in hash set? Okay, 1 is in hash set. Now what I can do? Okay, I can print this element 1 and element 2. Now no need to add this 3 into here. No need to add that. Or okay, we can add the 3 also. And again, I want to check now 2. Is my 4 minus 2, 2 is present in the hash set? Yes. So why we are actually doing this concept is, for example, my target is 4 and there is an element 2 and 2. What I'm doing, first of all, I'm checking this 2. There are only 2 elements in my array. First of all, what I'm doing is my 4 minus 2 is present in hash set or not. If 4 minus 2 present in my hash set, then I'm just simply returning this 2 and 4 minus 2. 2 and 4 minus 2. And if it is not there, then I'm just printing, like adding the 2 into the hash set. Now again coming to here, 4 minus 2 is actually there in the hash set. Actually, hash set, we can retrieve the elements in only O of one time, so that there is no additional time for searching the element. Okay. So this is the simple implementation. So instead of checking in this array, we are just simply adding that elements into the hash set. Then we are checking. It actually takes the O of n time. Simple. Now let us implement this. Then check whether it is working fine or not. Okay, first of all, okay, I have done the simple implementation and I have taken n value, array elements, target and hash set. Now what I want to do, I want to check. I want to traverse the element. Equal to 0, array less than n and I plus plus. Now what I want to do, element 2 is equal to target minus array of I. Now what I want to do, if my hash set dot contains, if it contains this element 2, then I just want simply same line, like this line. Copy this line and just simply paste this. Okay, then simply do that. And you have to add every element to the hash set. Here of simple implementation using the hash set. Now what I will do is, the workspace do some using hash set dot java. Okay, it is giving me some errors. Okay, sorry, not array of first. Oh, array of first. Let me take e2. We're actually storing that e2 plus array of I will be my target. That's fine. Very simple implementation. Again giving me errors. I have not initialized e2. Again save this. Again giving me errors. So what is that error? Public. Okay. Save this. No errors. Now Java do some using hash set. I want to give the things like 5, 5, 3, 2, 1, 2. Target is 4. Yes, 3 plus 1 is 4, 2 plus 2 is 4. That's a simple implementation of two-sum using the two-pointer approach in hash set. That's all. Okay, thank you friends. Thank you for watching this video. The coming up video is finding the maximum sum sub array using the Cadence algorithm. Okay, so subscribe to my channel Quick Coder to get notifications about the new videos. Thank you. Thank you for watching.